this is the state of the CAD currently. I think the biggest change that we made this past week has been switching to the Everybot Climber instead of Rust Hounds, just because the Everybot Climber seemed a lot more robust, and it just seemed a lot more reliable than the Rust Hounds climb. So yeah, that's what this is. I just copied the way they did their extrusions. We'll figure out the details later. That also meant I added this little piece of tube for the motor. Another big thing was this week Lamar tested some forms of the algae intake. So I have a kind of a mock-up of what that may look like. I'm still trying to figure out the details, but it's going to look something like this. It's going to slap down and hopefully intake the ball. It won't be a full possession of the ball into the robot, but it's going to be enough to where we have good possession of it. And then a big thing that we decided on doing yesterday was switching to adding more pneumatics, because we realized a lot of our motions or a lot of our pivots, they really only have two positions, with the only pivot that really needs more than two positions is the arm, which we're going to have to like tune and check and stuff. But like the intake, the funnel, like we really only need them to go up and down. There's no need to go in between. So we decided pneumatics may be a good option also, because as long as you set it up right, there isn't as many things that can fail other than leaks or user error. That also meant, the reason we also chose that was that means we could make the algae intake compliant. So our original plan was to do some sort of max tube with a roller at the end, but we thought about it again, and if that's really rigid. So if we ever run into something or something runs into us, that's either going to bend the whole intake or bend whatever it's pivoting on, and that's going to cause a lot of issues. So instead, we're going to use probably polycarb, and I'm trying to find a way right now to get pneumatics to work on it. My current plan was to basically have this and just have this back end of the pivot extend further inward to the robot so that we have a place to mount the clevis of the cylinder. And so when the piston's retracted, it's in this stow position. And then when it gets pushed up, it'll go down into the intake position. We also chose pneumatics because it allowed us to do cushioning. So again, it's adding more compliance to it. Whenever we get hit or run into a wall, it allows our intake to basically float to where we can still get the compression we need, but we can comply to the ball to the size of the algae. It should help intaking. It should just make the intake a lot more robust. So yeah, I think that was the biggest change. I also added a hard stop on this funnel. It really wasn't much. We just made this piece a little bit longer so that gravity is just going to hold the funnel in the right place. And then when we need to pivot, we can activate pneumatics that will pivot it upward and out of the way. So yeah, in terms of build, we did yesterday end up putting the modules on the rails, which was good. We got them in the right orientation and put the spark maxes on there. We just need to figure out how we're going to put the electronics on. Another change actually was, instead of doing grid pattern for the drive bracing, we're going to switch to max pattern. And that has to do with how we're going to try to do the elevator. We're going to try to copy Rev's elevator, which kind of requires that we use a max pattern here on the drive brace. Again, it shouldn't be that big of a problem, but it's just something to note. Yeah, I think that's all what I remember, that's all we've done this week. See, I added bumpers to the CAD as well, but yeah, that's about it. Anybody have anything?
Is the battery finalized?
The position itself is finalized. I'm still working to get the details kind of ironed out, but it's not gonna change how the battery is made too much. Like it's gonna be in this area, or sorry, it's gonna be over here, opposite the climber. So yeah, so the weight is gonna be a little bit more even because it's opposite of the heavy climber. So it shouldn't affect the weight distribution too much. But yeah, right now I just have a battery in there, but I should hopefully by the end of the next couple of days I'm gonna have the whole battery assembly in there, so we can start finalizing that.
Probably need to think about a compressor too.
Yeah,
That's another
make sure.
heavy
Yeah,
object that needs to be put somewhere, probably opposite of the battery.
yeah, it's gonna be either here or over here probably. We'll figure it out. These motor plates can also be ignored. This is not how we're gonna do it. We're gonna do it a different way. So, yeah.
Yeah, I mean, there's a lot of stuff associated with the pneumatics.
Yeah.
We have a high. I mean, there's a lot of weight, and we're actually down. What is it? 10 pounds from the regular weight. They reduced our.
Yeah, we're at 115 now.
115. Yeah, so we got 10 pounds. I don't know. I mean, if it's just two motors are pretty compact, and it's easy to store. We got plenty of power, so I don't know. I mean, the good thing about pneumatics is if you have the compressor and you have the tanks, you could run like 5 different levers and stuff like that, or cylinders or whatever. But to do 2, it's a benefit. Cost benefit analysis for 2 is just get some motors. I don't know. I don't know. We also have problems. We've historically had problems with the cylinders bending, or those kind of things. That if you got a motor, maybe the chain slips or something like that. But it's you can usually tension it up or whatever. Anyway.
I think it is an interesting problem to think about. Ideally, the lift and the coral scoring should still work even if our pneumatics has an issue on the field.
Yeah.
Well, depends on what kind of issue. If the algae intake starts falling out, then that could be bigger.
Yeah. I mean, just getting through inspection is, they have to do the pressure test, and it seems like somehow maybe it's just us, but we always have leaks. And then we say, well, it's probably not that bad. And then halfway through, we're out of, nothing works. I don't know. I don't know what thought was in there, but the weight and the we used to do this all the time, and I don't know. We kind of stopped doing it because of the weight and the all the problems we had with it. It's like, I mean, I don't know, but where do you put the tubes on there? Where do you put the compressor on there? If you got 2 motors, you put a motor here and a motor there, you maybe have a bigger gear reduction, so maybe a bigger gearbox, but I don't know.
My main concern about the motors was programming, just because we've had trouble with like doing arm stuff or pivoting stuff with motors with motors as well. And my thought was that, we already have this stuff that's gonna definitely have to be a motor.
Yeah.
But these two, we don't really need the utility of a motor that we would see in something like this where you have multiple positions. That's just not really there for these 2 pivots. And that was really the main reason why. I just thought it would be a lot easier to program. It's extended or retracted, and there's not much to it. So, I don't know.
What's everything you're trying to run with pneumatics, by the way? Sorry, I didn't hear that.
The two things we're trying to run was this algae intake and the funnel pivot, and it would have 2 points. It would have two cylinders each, so one on each side.
Um, One of the nice things about pneumatics is that you can like run small like levers and movements without much more cost. Something you might want to think about is like, I don't know if the Everybot climber you can like run it with pneumatics, but it might be something you can like think about. So I know there's like the part that like splits open, right, to hold onto the cage. You know what I
To my
mean?
knowledge, I'm pretty sure that's just some sort of rubber bands, a system of rubber bands that they
Oh, I'm
use.
not sure. Is it rubber bands? I thought it was a motor.
It didn't look like anything. The clamping part at the top, it didn't look anything like that was motorized.
Okay.
I could be
All
wrong.
right.
I don't.
Yeah, I mean
Yeah, it's like
it's a good point. Like instead of, I mean, it's a complicated spring-loaded mechanism for every bot. Using pneumatics to hook is possible. I think for now, you could throw a compressor in the CAD, and if we change our mind, we change our mind. But let's just plan for it right now, and then I really want to focus on the really critical parts of the robot, which is the lift, the drivetrain, battery, um, and I think we can work out some of the other fine details with pneumatics or actuated algae thing later. Um, let's just, I mean, if our lift isn't working right, then we're in big
Yeah.
trouble.
Yeah, and the algae thing, it could be unpowered too. I mean, that's what,
Yeah,
you
exactly.
know,
So
I
I think,
mean,
the algae thing will be a pivot. I mean, if we want to get we could even get like a really simple, like, um, you know,
string and a,
string. Yeah, we just pull the string back and forth with a pulley. But regardless, there's like three or four ways to do that pretty easy. Um,
and I don't even know about the funnel if it's needed. I mean, if we get the lift figured out, then we'll figure out if we need the funnel
yeah,
to do anything. So,
exactly. Funnel is like even more simple. Like we could literally have a string that just gets pulled, and it just because it doesn't have to have any. There's no real moving
Yeah.
interaction with like a ball or anything. It's just getting it out of the way. Um,
yeah, just like turn the motor on and let the spool build. It doesn't have to go back. It's a one way,
yeah, exactly. We
swing.
could even have it as just a spring loaded thing where as soon as we open it up, it
Oh,
just pops up and never goes back down.
yeah, yeah. So anyway, but if we don't have to worry about all that other stuff, and we could get the arm, the arm and the lift working, and kind of just like you say, we have to do the motors for the arm. So maybe we get better. I mean, I wouldn't mind just not having the other stuff now, and then we get the lift that works and the arm that works, and then we could use the Rust Hounds, um,
Yeah.
passive thing. And if the climber, is not going to interfere, or we could do something simple. You get all this other stuff on there. It's a lot of complexity, and it's going to take a lot of time. I don't know, but if we get the left wrong, we're not going to be able to score anything. And Coral is kind of our number one. I don't know. So I mean, I don't know.
Let's just keep it reserved. Like you have it, you've catted it, we have a space for it, we can work on it. It's kind of like the climber. Like think to the climber last year. We had it reserved. It took up some space. It was tough to pack in. We ended up not using it very much. Uh,
Yeah.
this year might be a little different, but we'll still reserve the space. And if we get time to make it work, amazing. But if we don't get the lift and the arm working, we're in big trouble. So let's let's get into those fine details. I think you've got a lot of stuff reserved. The big items I really want to see in this CAD is like the PDP. We need to have that next to the battery, make sure we're okay with that positioning, and then I guess if we might have pneumatics, we probably need to see where the compressor is going to go just for CG and stability. I think the compressor is kind of small now. It's not as big as it was in previous years, so we can probably make it work. And then any other really big items that we're just missing, guys, that we haven't integrated into this thing?
Well, I don't know if we're missing big items, but there was a good argument made yesterday for like rethinking or rethinking what we want to do with this robot. Because realistically, like if we get rid of this climber, then let's just say we decide like soon that we're saying, you know what, screw climbing, we're not gonna climb. We can make this robot. We can like take away so many from this robot. We can basically just forget about the climber and then kind of just forget about the funnel because, I mean, yeah, we had it for jams, but I don't because of how the coral is going to get loaded into the funnel. I don't think there's much chances for it to jam as often as we may think because they have it to where you can just drop it in vertically, and I don't think it's going to jam too much that way. And so if we get rid of the climber and we just say don't climb, I mean, we don't really need a pivoting funnel. This can just be static and then keep everything else the same.
Well, I kind of agree that we just worry about the passive intake for the algae and leave the funnel where it is, and then we'll see what's going on. But no, yeah, I don't get too far ahead of yourself. If it actually fits and doesn't need any fancy thing, then don't worry about it.
Yeah, you've got the space reserve. I don't think we need to give up on it right now. I mean,
Yeah.
I think their priority now is really just make sure that everything fits, and then really hammer down on the lift to make sure it's accurate. Because we found out Saturday we were missing some dimensions because of the way the spacing works.
Yeah.
The other thing is on the algae intake. They had something at the bottom, wheels at the bottom, just to. They didn't rotate, but they held the algae there. So you might think, I don't know if you found a different experiment to hold the algae in. Maybe it'll fit on the bumper, and you have something behind the bumper. But that's one of the things that we discovered was you needed something to hold the base of the algae. It was passive. It wasn't there, and it could be a bar or something like that. But that was just experiments. I mean, because when we kicked it, we needed it to grab. If we kicked it and it wasn't grabbing, then it just kind of went out. I don't know. But it was kind of hard if you have it trapped at the bottom and trapped at the top. It's hard to kick out.
So we got a couple snow days coming up. Where
Yeah.
do you
Yeah.
think you want to be, Cedric, in terms of schedule?
I don't know. I'm not 100% sure where I want to be. I just want to like get to a point where I can like um I just want to get to a point to where I can feel confident that everything is in there and everything is going to work the way I want it to. But I don't know what it's going to take to get to that point. It's really my main concern.
How about in? I mean, you guys don't have school. What? They cancel it Tuesday, Wednesday.
Yeah.
So how about by the end of Wednesday, you feel pretty confident that we have all the details of the lift and the coral arm?
Yeah.
You can almost leave everything like you have it. Maybe add a couple big items like the power distribution board and the compressor, but like just
Power
focus on the
switch.
lift.
Where's the power switch go? Yeah.
Yeah, power switch. Yeah, that's another big item. But yeah, I'd like to see, I guess, with the rev brackets. Do we think we have enough brackets to put it all together?
I mean, how many did we buy?
I'm pretty sure we have like I think we have enough for like 1.5 elevators. I'm 90% sure.
Okay.
So
You bought a lot of different different types, so they
Yeah.
should all they should work.
yeah, I unfortunately I went to the CAD that Andy had with the single stage, and we are going to need some more end pieces, or so a lot of times like we need an end cap to mount to. So
I see.
I
Just send me a
looks
list
like
of what you
okay.
think we
I'll
might
send
need.
you a
Let's
list of
just
it. Yeah,
let's just try to get
yeah.
them before they run out, because I think everyone's gonna be moving
It's.
pretty soon.
I think you're right. Yeah, I'll do.
Cedric, I would look at like the sheet of like what we have, and based on like the blocks that we have, you might want to try and make something work with them,
Yeah.
right?
So yeah,
Yeah,
Well, Les, you already put together the inner box, right? So you should
yeah.
that
probably
already
map
used
it
up like
CAD.
they already used up like 4 of them, right?
What's that?
They used up 4 of the bearing blocks, I'm assuming.
We use the face plates, the 4 face plates, and the end pieces. So I think right now we have. I think we're the next stage. We need a lot more end pieces to complete that. I mean, we have plenty of. And we might be able to do there are different things. We had the end caps, but we might be able to do like the side mounted version of those, at
Yeah.
least for the top. So yeah, I think there are some options.
There's a lot of options. Yeah. So the only people that make like the end mount ones are like Rev and WCP, I think.
Yes.
So something to think about is like all these other like different versions of the elevator uses the face one, so you could definitely make it work with that like in mind.
Yes.
You know what I mean?
Yeah,
So-
we could do we could cut the
Can we
gussets.
pull
No.
up the Rev starter bot, and maybe we'll just all look at that together and make sure we. I think I posted the link in Slack too. If you want.
Is it in just the lift or the whole bot?
Oh, I guess that was. Yeah, maybe they don't have the Rev starter bot.
Oh, there it
It
is.
was just,
Yeah.
it was just
This is the
it was-
lift.
I guess it
This
was
is the
an
lift.
example of a lift using Rev.
But I think this is probably what they did on the starter bot. I'll have to look again.
I mean, yeah, I think this is a good learning tool. So
Yeah. Yeah. I think you're right. We could do it with face gussets, and we could probably fool around a little bit. But right now, say on the bottom, they use where all the screws are. There's an end piece,
Yeah.
and then this piece is an end piece at the bottom, and then you can see there's like 2 end pieces that it's connected to. So it's end piece. So I counted, and it's like we need like 8 of the end pieces for this inside mount, and then there's 6 on the outside lift, and then that little bar that goes across is another 4. And I'm not sure exactly what thickness, but we have, I think the light would be 8, and the outside, if it's the thicker one, would be 10. So there's like, what's that?
I guess changing a topic on tensioning, how do they tension the way that chain is done for the lift? Does that slide back and forth?
They have a turnbuckle here, but this one,
That chain, yeah, the small chain.
I don't know if they tension it.
Oh,
Make
just
it
count.
perfect.
Yeah, that's right. I mean, it is 4 inches or whatever. So
Yeah, this is I think I tried messing around with this. This is like 16 tooth 4 inches, and I think when I put that into the calculator, it was like an even and was basically perfect. So
okay, yeah. So we do have a lot of 16 tooths, and yeah.
Is everybody okay with this style chain? The same mechanism.
The only thing is the carriage on the rust hounds needs to move first. So
yeah,
Yeah. So I don't know. I mean, they use a string and then have a carriage string on the bottom. So, you know,
We don't since we're using a different style, I guess you could say. We're using a chain here for the first stage. We could just look at doing a cascading elevator, which basically it's going to effectively do the same thing. It's just different in how it moves. And there's a lot of examples like ThriftyBot. So we could just look at that and try to imitate that if we want. We'll have to figure out the details, obviously. But
So if I remember right, Cascade doesn't allow us to start at the
the
A
top.
position, but
oh yeah, that's true.
I
Yeah,
guess we could have the arm kind of resting, so it's not, even though the arm isn't completely down. Does that make sense? Or we could
yeah,
just string it where the arm never goes past the point we need it to, and that is the down position. But I think either way, Cedric, you work through, a version that you think is clear, and then we'll have to think about it a little bit before we start building. But I think you're on the right track with first stage chain, some sort of string that is some combination of Rust Hounds and ThriftyBot, and maybe you even look at the starter bot that the Rev has and see if that has some other details in it. But but yeah, I would start working on these fine details. This is probably where you need to put your time the next 2 days, because the sooner we can build this and put it on the drivetrain and test it, we're going to feel a lot more comfortable with what we're doing on this robot.
yeah.
I
Cedric,
think the Chief Delphi post has some talk about the lift and how they threaded the lift.
Okay.
hey Cedric, do you understand what Andy meant by it doesn't work as a cascading elevator?
Yeah, no, I see what you mean now.
Yeah, because if to start a cascading for it to fully fold in, you need to
Everything has
have
to be in
the
the
middle.
bottom.
Yeah, it needs to go to the
Yeah,
bottom. That breaks
that
it.
would
So
work for this.
Unless the bottom is where we pick up the coral, we could put a hard stop and just have it stop there, right? It doesn't have to go all the way down. So, something to think about. I don't think it's totally out of the question. Just start building it and share your screenshots, and we'll just keep,
Yeah,
considering it. We haven't built something just like this yet, so we'll have to spend some time thinking to make sure it's logical. And yeah, I think we're on the right track. So.